we're going to look at what happens when we graph these. And normally I would get you to use graphing calculators, but because we want to go faster, I'm going to show you what would happen if you graph this yourself. And we're going to look at group 1. And all the graphs in group 1, hope you all notice that they are all parabolas over lines. I'll write lines as mx plus b. And we're going to notice in group 1, because if we notice some patterns, that will help us graph things. Group 1 is all about the degree being bigger in the numerator than the denominator. The degree of a function is the highest exponent. So a parabola has a degree of 2, a line has a degree of 1. And so when your degree is bigger in your numerator compared to your denominator, we're going to look for certain patterns. Okay? So in this first one, it has a non-permissible value of -1, but in this situation, the non-permissible value didn't end up with an asymptote. Non-permissible values sometimes are asymptotes, which we saw in the getting started, but sometimes you're going to have holes in your graph. This graph has a hole in it. And we draw a hole by drawing an open circle, saying when the graph got there, it just never hit that point, because that point is not allowed. This one has no vertical asymptotes, no horizontal asymptotes, but it still has a non-permissible value of -1, and that -1 ended up with a hole. You can label holes. This one's going to be -1 comma something. We're going to figure out how to label the y value in a bit. Next graphs, still part of group 1. Slide them all in here. I will give you a little bit of time to sketch all of those. And then we'll discuss the properties. When you sketch this one, add a hole there at -2, comma something. And on this one, add a hole at 2, comma something. On the second and third one, if you have a red pen, add horizontal asymptotes at x equals 1 and x equals -2. And we're going to find out that these ones have diagonal asymptotes as well, called oblique asymptotes. I know, crazy. Thought asymptotes were just vertical and horizontal. Now we've added diagonal asymptotes. Alright, is everybody done drawing all the graphs? So I want to make some notes of some observations. I want you to notice that in group 1, if the degree is bigger in the top, you will not have any horizontal asymptotes. I also want you to note that your non-permissible value sometimes is a hole, sometimes is a vertical asymptote. And we're going to find out how to tell that right away. So the key to graphing in this unit will be a skill that you've used a lot. You need to factor. So before you start graphing, the very first thing you're going to do in a question is you're going to factor everything that you can. So in this first one, I could factor the top as a difference of squares, x plus 1, x minus 1, and that would all be divided by x plus 1. Do you see anything you could do with this? You could simplify, right? The x plus 1 factors are identical. You could simplify this, and then this would just become y equals x minus 1. You know how to graph y equals x minus 1. It's a straight line. Did our graph turn out to be a straight line? Yes. But even though the non-permissible value canceled out, the non-permissible value is still there in the original equation. The original equation tells us that x cannot be minus 1. But once you've simplified it in the line, what would happen if you plugged in x as minus 1? What would y be? If I plugged in minus 1 for x, can you see that the y value would be minus 2? And that's how you find the coordinates of your hole. You're going to have a hole if your non-permissible value cancels out, you get a hole. If your non-permissible value does not cancel out, it'll stay as a vertical asymptote. So if we look at the next group of questions, if I factor this first one, sure enough, I have the same factor on the top and the bottom, it cancels out. And after it cancels out, I get a straight line, which is what I ended up with. What would happen if you plugged in negative 2 into this line? You would get negative 3. And that becomes the coordinate of your hole. The next one does not factor. The top doesn't factor, it's just an x squared. And so your non-permissible of 1 stays, and because it stays, we have a vertical asymptote. When your non-permissible value cancels out, you get a hole. When your non-permissible value stays, you get a vertical asymptote. This one I can factor. I can factor it, but none of the factors are identical. So again, the non-permissible value stays, and I get a vertical asymptote at minus 2. And the last one on the top, I have a common factor of 2x that I can pull out. And that factor simplifies. So because my non-permissible value simplified away, I get a hole. My new equation is just y equals 2x. So when x is 2, y would be 4, would be the coordinates of my hole. This is group 1. Group one, we're looking at what happens when you have a parabola divided by a line. Okay? Characteristics. Okay, no horizontal asymptotes. We've got holes and vertical asymptotes. We also have the possibility of diagonal asymptotes or oblique asymptotes. So what are we going to be asked to do in this unit? You're going to get questions like this, and it's going to say graph. And you have to be able to draw the graph on your own without a calculator, labeling all the asymptotes, all the oblique asymptotes, all the holes, and know what the shape is going to look like. Okay? Right now, we're looking at 3 different groups as to 3 different patterns of questions. Pattern 1 is when the degree is bigger in the top, like an x squared on the top and an x on the bottom. Pattern number 2. What happens when you have the same degree on the top and the bottom? And if you have a red pen, draw these graphs. And add the asymptotes. I would like you to either use your graphic calculator or Desmos at home and have group 3 done for the beginning of class tomorrow.
When we can start to get practicing this.
Probably when we're 1 unit away. But I can, if you're really wanting to get started, like the problem with starting early, we still have 3 units left. So there'd be so much on there that you wouldn't know how to do yet. The second and the third one could be factored, so I'll just write them in factored form. Again, since each of your non-permissible values doesn't cancel out, in each of these, they became vertical asymptotes. If something canceled out, these graphs could have holes as well. Okay? Now, finding the horizontal asymptote. There's a technique that you can look just at the equation and tell what the vertical asymptote is. That this one's going to be 3, this one's going to be 1, and this one's going to be -2. And I'll add 1 in here, see if you can figure out, I'll put, here I have another one where I have a parabola on the top and a parabola on the bottom. So it's the same degree on the top and the bottom. This one would have a horizontal asymptote at -5/4. Can you see the trick for figuring out the horizontal asymptote? So not only will I show you what the trick is, don't worry, if you don't see it, I will show it to you. I'll also explain why it works that way, okay? So the trick is if you just think about the highest degree on the top is the 3x, the highest degree on the bottom is an x, and you just did 3x divided by x, you would get 3. In this one, the highest degree is an x squared, so if I look at the x squared and the x squared, 1x squared divided by 1x squared is 1. And in the third one, I've got a -2x divided by nx. -2 divided by x, and in the last one, a -5x squared and a +4x squared. I'll explain why that works tomorrow.